Hello, this is Quentin from ServiceNow, and today we'll be covering Stream Connect for Apache Kafka, a specific deep dive on a specific technique to consume ServiceNow, to consume Kafka data from ServiceNow instance. But I'm going to go into the weeds because there's different ways to consume Kafka data from your instance if you have Stream Connect for Apache Kafka. And on that slide, I'm going to try to explain one of the solutions I got from Amila, who is one of our engineers in the automation engine business unit of ServiceNow. This comes from a request I got multiple times from customers where they ask me, hey, with Stream Connect, I'm limited to a certain number of topics I can create. I believe it's 30. Don't quote me on this. I think it's 30 topics that a client can create in Hermes. So they have to organize the Kafka message in a way that they have to share topic for different type of message. I'm going to give a specific ServiceNow example that a customer gave me. I want to have an ITSM topic in ServiceNow and everything related to ITSM coming to ServiceNow from my external system will go to that ITSM topic. It could be incident type of data, it could be change, it could be anything ITSM, CMDB data, etc., etc. Out of the box, when you look at the RTE or Robust Transform Engine, Transform Map, it's kind of complicated to mutualize or share one topic for different type of data that's coming in, especially when your when you have more than one target table, which is the case. If you have ITSM, you have one Kafka topic, and you're gonna receive from that Kafka topic data for incident, change, CMDB, CI, maybe 50 different type of tables. How do you do that? So I'm gonna answer that, showing a demo and deep dive. There is a way to do it with Flow Designer. In Flow Designer, you could easily create a flow trigger. With Stream Connect, you get a Kafka flow trigger and parse the header of the message. And depending on the header, if you send within the header of the message from your external system, if you send a table name or doesn't matter an identifier, then you can apply a logic in your workflow to basically pick the right table. Just do a mapping, and that's fine. Flow Designer, it's fine. I wanted to cover and address the question that I got from a customer who wanted to use our ETL, Transform Map, or Robust Transform Engine. So, and it's not, to be honest, it's not that easy out of the box to do that. So I'm gonna go over that. Yeah, I'm not going to use ITOM or ITSM. It's a very simple example, but that should help understand the concept and help you reproduce that similar configuration. So I'm taking an example of we have an external producer. In that case, could be a system in your environment, your data center, a system that's going to be updating. So it's simple here in that example. That system produce a bunch of address data and employee data. Right, so there is a different Kafka message being produced by different system, and they contain different type of information. So the structure of the payload is different. But for that use case, since we're talking ServiceNow, we know the data we send to the Kafka cluster needs to go in different tables. So the question I got from a customer is, how do you do the routing, the triage? How do you know that when we receive that payload, because it's only one topic, so how do you put the logic to assign the payload data and map it to a target table? So that's what I'm going to be covering here. Here I'm representing a topic that you'll see in my demo. I've named it multi-table. It's just a Kafka topic in the Hermes environment. On the left side is all the configuration point. So if you want to reproduce that type of configuration in a lab or in a test environment, you're going to have to create a Kafka Script Consumer and as many ETL definition that you need. So if you have 2 tables, you need 2 ETL definition. If you have 10, you need 10 ETL definition. In the ETL definition in ServiceNow is where you map the field from the source data to the field on the target table. That's how you do the mapping, and an ETL definition is really tied to a target table and a specific data structure as a source. So that's where we do the magic, but the way you capture the data from that unique topic, in my example, I really want to show that you can have one topic that contains different type of payload and put some logic. So based on the payload, you can update or create record in different tables in ServiceNow. And for this, you have to script and you have to create a Kafka Script Consumer. So I'm gonna basically do some reverse engineering and show you how it was configured for that little demo. And I want to give the credit to Amila. This is Amila, one of our engineers, who has created the script and explained this to me. I'm just repeating what he explained to me. So you can leverage that information for your own use case and environment. So that was, I hope the slide helped. As you can see here, we are targeting table name address, and here we're targeting table name employee. You don't have to stick to that, the payload you formatted the way you want, but here we need to indicate in the payload what's gonna be the target table, because we use that in our logic. We use that information to map to the right ETL definition as we process the payload with the script consumer. So you have somehow to pass to tell in the Kafka message. It doesn't have to be in the payload, could be in the header, could be a key, doesn't really matter, but you have to pass, as a producer has to pass the target table or an identifier. So let's I will come back to that slide. Let's do some reverse engineering. I think I'm gonna start by showing you the table, the ETL definition, and a Kafka script consumer, and I will do a live demo to show you that it's working. So the two tables I'm talking about, they are here a simple table. It could be an incident table. Yes, obviously it's a lab. I'm just oversimplifying things. I have one employee table. It's empty, but on purpose. We'll feed that table using the ETL and the data coming from Kafka. And we have an address table here. Now, this one I'm going to clear up the record because I don't need that. The goal is to check if it works when I produce in Kafka. So that's my two tables here. Now we're going to go in the ETL definition and see what we created. So in ETL definition, you'll see that you have two. Employee definition and address definition. I have two because I do have two target tables. So as I explained before, it's 1-to-1. You have one ETL definition per target table. So if you have 150 tables that you're targeting, you're going to have to create 150 ETL definition. So here there is an address one. So I'm going to open those. Basically, just put a name. I already covered this in other videos. You can search in the channel, but the way it works in the entities is where you define the structure of the data source and kind of the structure of the target, record. So if I start with the target, you can see that I'm targeting a table. So I know that address definition, that address ETL definition, is to target that particular address table. If I open it, you basically just see the different field for that table, the field that I'm gonna be populating. And I think there is a generate field button, so you don't have to manually, if there is 10 field, you just click. I'm gonna go and do it again. Click on generate field and it's gonna add all the field. Because basically it's reading the table, and for all column it's gonna add the field here. So now you know what are you targeting with the ETL config, and now the import set. This is basically you put the JSON path. If you remember my payload, it's formatted that way. Actually, I should show it to you so it's easier to understand if you're trying to represent this. Here in that second entity, I'm representing the data source. So you need to be careful. It's all case sensitive here. So I'm gonna go show you the JSON, an example of the JSON. I was looking at the, which one? The address one. So city and state. Here, so table name address, data, so let's see. You have your data object, and I don't know how you call it in JSON, a sub-object or the element, and you see city and state. All right, so I'm telling ServiceNow the structure of the payload that I'm using as a data source, because that's the payload I'm reading from Kafka. So I'm doing this in there. Going back, once you've done that, again, and there is documentation that explains how all of this. This is not only just specific to Stream Connect. This is how the ETL works in ServiceNow. If you go to RT entity mapping, basically you map the source with the target. That's all you do here. So you put a name and then you say what is the source and what is the target. So the source is the import set is basically the data structure, the JSON field that we indicated in that configuration, and my entity is my address table. And that's it for this. So you do this for every single table that you have. Obviously, it could be a little bit repetitive. And you do. If I look at address, it's going to be the same way. I look at address, so you have an import set where I define the structure of the JSON, city, state, and I think we already looked at the address one. I think employee, I'm going to show you the employee one. Employee one, yeah, data first name and data last name. If I go back to the here, because I'm going to also have some payload that's going to have data and an element, first name and last name, and it's really important to make sure you have if you have here a capital N. So it's case sensitive, so make sure you spell it correctly, the name of the path. If you put last name lowercase here, it's not going to work. It's expecting is going to be basically parsing the JSON to grab those fields. So anyway, the ETL definition is going to look pretty much all the same. You may have different number of fields and etc. It doesn't really matter. So for my example, I have employee definition and address definition. So we've covered ETL definition address, ETL definition employee. And that's what we covered. Now the last piece, that's probably where it's a little bit trickier. It's the script consumer. So I'm going to try to go in Kafka Script Consumers. There are some here that was there in my demo instance. Let's ignore this. But this one, the one that was created by my coworker, Amila. And this will need to be improved if you want to do this in production. I can share that script. Definitely, you probably need to put some error handling and improve a little bit. But that script consumer basically grab the Kafka message. So if ignore the script for a minute, when you create a Kafka script consumer, this is basically where that script will subscribe to a Kafka topic. And that's where what I've done here. I clicked new and point that consumer script to a topic. So at this moment, that script has access to every single message that arrives in real time. And we want to leverage those ETL definition to do something with those Kafka message. And how we leverage those ETL definition is from that script. So what my coworker Amila has done here in the, and there is example in the doc for that actually, but basically what those sysid, for those who may ask what it is, those sysid is basically the sysid of each ETL definition that I created. So here we basically hardcode them in a script, but as you can imagine, you could store the mapping, table to ETL definition somewhere else in ServiceNow instead of hardcoding that. But this was just a quick test. And then I'll let you look at the script, but basically it's creating the data structure, and using the mapping to map the data extracted from Kafka to the ETL definition. So we're using the right ETL definition if it contains the employee or if it contains address table. So the ID here at the bottom is kind of important because it's where you define which ETL definition you want to use for the robust transform engine transformer here. That .id here. It's the ID that you have here. So that's how Amila created that script. There is example in the doc. So here I'm looking at the RT transformer developer doc, and you'll find similar logic here. It's basically kind of the same, right? So you can it's documented. Now I'm documenting that particular use case from a Stream Connect for Apache Kafka perspective, because it's a bit tricky if you never use that, but the RT transformer, it's something well documented, right? So the tricky part that I didn't know before I talked to our engineer is how to do the dynamically, basically assign specific ETL definition so I can target different tables, even though I'm listening, I say listening, but consuming only one topic. So now I have multiple messages that arrive in the same Kafka topic, but with that script, depending of the payload, I'm leveraging a specific ETL definition that's gonna tell the system to create the record in the right target table. That's what it's all about. But so as you can see, it's not that complicated. You have the ETL definition. It's pretty straightforward in that piece of script. Me, I will try to map. If that was me doing this in pre-production, I will store this in a custom table somewhere. Or I even use tag on on the tables themselves, on the target tables themselves, put a tag where, I don't know, I will store an ID or something, but this could definitely be the more dynamic. But the magic sauce is there, right? Assigning the right ETL definition. So let's see if this works. I'm gonna be generating the data, so I'm gonna be using this type of payload. So basically, I'm gonna parse through that file, and for each file, I'm gonna send the line. For each line, I'm gonna create a Kafka message, basically, right? And automatically, it will arrive in Hermes in my only one topic, and it will be creating a record in the right table. So if it has employee, it's gonna go to the employee table. If it has address, it's go to the address table. And it could have, like here, Amila just did a test with 2 fields. It doesn't matter. Could have 2, 3 fields, 10 fields. You can add more logic. As long as you have the right ETL definition for the field mapping, it's gonna work. Right, so let's run this. Here I have a script just to show you everything. I'm gonna open my little script that I use as a producer, pardon me. So my script, I have plenty of script that I've created here. Produce, I forgot how I call it, employee. So if I open this, basically what I do, I'm pointing to my instance, Bootstrap server, and I'm using the Kafka producer script right from my computer. I'm parsing a file that has all those lines that we saw, the JSON data that contain all those employee and address, and that's all I do. So it's pretty straightforward. I'm simulating a system that will create data, basically, using via Hermes, producing Kafka message via Hermes. So let's run it, and then see if it works. Producing employee. Produce employee, maybe, huh? Yeah. So this just goes over each of the line, and it's slow because that's just the way the Unix script. I'm not an expert in Unix script, so it's just parsing each of the line and sending to Hermes in that topic. Actually, as it's doing this thing, let me go show you that topic. So you see everything in my demo environment. That topic I just created today is called multi-table. That's all it is. And because I've configured my script transformer to subscribe to that topic, I can see it as a subscriber here. Right? You see sub. So that means that I have that script, that listening, and as data arrives in that Kafka topic, it goes through that that RT transformer and use those ETL definition. So now I know the data is being processed as we speak. So I may have like a statistic and things going on here. I can see produce message. Checking the time. Yeah, that's just now. See, I see message being produced, and then we're gonna see consume 9. So the script consumer already consumed those. So let's see if I have data in my tables. I hope so. Yeah. So I do have my data in my address table, and I do have likely data in the employee table, right? And you can get more. If I go, I wonder if I can show you some more detail where you can see, yeah, the import set being processed. If you search for import set, yeah, there. Yeah, here. If you go into import set, you can actually see the data, right? The data that came from the import set, the row being processed and everything, right? So that's one way to see also if the data came through. And I use this also to check for some reason if the script consumer, when I was setting this up, I was missing a bracket as I was producing from an external system, and the script consumer obviously could not parse the JSON properly. So I go there to verify that I'm, sending the right format, the data in the right format. So that's, now you can see, that's where I go for the import log and everything. So if it's not working when you try to reproduce things, I would recommend you go check the import set in there. So that's what I wanted to cover. I know it may not be structured, the demo I'm recording here, but I also do this for me so I don't forget some of the steps, and I have this somewhere in my archive. But that's, if you look at that slide, that's what it is. One topic only, sending one producer or multiple producers sending data to ServiceNow in only one topic. And we're using a script consumer basically to do the triage. That's probably the easiest way to say it. And to perform the triage, we have implemented some logic in the script to map, based on the table name, map the right ETL definition. And from there, because we use that API, that RTE consumer in the script, map to that ETL definition, we know the data is just going to get mapped to the right table. So I haven't tried this with hundreds of different tables, but I'm assuming this will be no problem. But if you guys test, if someone listening to this test this at scale, I'll be happy to get your feedback, and also if you improve the script. I will share the script somehow in the description of that video, so you can take it and modify it and maybe share back to me if you improve it. Thank you for listening to this. Bye.